Good evening, everyone. Can someone confirm if I'm audible?
Yes, sir.
Thanks. Yeah, so maybe we can start now. So, welcome to the live session for the course Digital Circuits, which is taught by Professor Shantanu Chattopadhyay from IIT Kharagpur. I am Anant Singhal, a PhD student from IIT Jodhpur, and today I'll be assisting in solving some of the assignment problems or similar assignment problems that have been given to you in the week 7 assignments. Uh, let's go to the course outline. So as we have already covered some part of the sequential circuit in the last week itself, so we'll be covering some more similar problems or the relevant problems that have been given to you in the week 7 assignments, which is related to sequential circuits. Some problem might also include this particular topic, which is counters. Maybe some topic will also include shift registers, but all of these topics are pretty common and comes under a common topic, which is as I call as the sequential circuit. So I would say these particular topics are very important even for your exams as well, because these topics are, I mean, covers the basic or the fundamental of this particular course, which is digital circuits, because in each and every memory we have these kinds of circuits. So yeah, uh, we have already covered or completed the combinational part in the first 6 weeks itself, and then from the previous week we started some of the sequential circuits. I hope you have already gone through the video if you have not attended the previous lecture. So maybe we can start the lecture now. Okay, so this is the first problem. It says assume initial contents of all the D flip-flops are reset to logic 0. So what basically does it mean that all the initial, that is the whole D flip-flop, it's reset. That means it is like something like this, that it does not contain any logic 1 inside the processor when it is not operated. Then it says the serial input is tied to logic 1. So serial input, which is this, it says that it is tied to 1. So this is always 1. No matter what happens, this will always remain 1s. So now the problem is, what are the contents of the registers after the 3 clock cycles? So we have already covered some of the problems, if you remember, in the previous lecture about some of these kinds of problems in which we calculate what are the different input output at each and every cycle. So maybe just to simplify this, I can maybe name this as 3210, and so this would be Q3, this would be Q2, this would be Q1, and this would be Q0. So the question, basically what I'm trying to say here is, the question is the Q3, Q1, Q0 is initially 0, 0, 0, 0. So now the question is asking after 3 clock edge cycles. So since this is positively X triggered, so after 3 cycles, maybe like this, and like this. So it is asking about the status of this. So are you able to understand the question? So let's try to do it. Maybe that will make it more clear. So what I am trying to say, so let's say I'm making a block as clock, then Q3, Q2, Q1, Q0, right? So initially when there is, maybe I can write initial only. So initially all the contents are 0. Now when the first clock cycle is applied, so we know that for a D flip flop, what is Qn plus 1? Can anyone tell quickly? What is the next state of a D flip flop?
One.
Sorry,
Zero is zero.
0.
It will come zero.
So I'm asking a general notation. Let's say for a D flip flop, yeah. So it is D. So basically here the Q3 plus will be D3. Here the Q2 plus will be D2. Here the Q1 plus will be D1, and so on. This is what, so it says when the first clock cycle is applied. So this Q3, because the Q3 plus is D3, so this will shift here, this 0 will shift here, and this 0 will shift here and this 0 will shift here. So that basically means, first of all, this 0 is coming here, this 0 is coming here, and this 0 is coming here. But now since this is tied to 1 always, so this 1 will come here. So the next state, or the after the application of plus clock, the output will be this. Is it clear to everyone? This is the basic step. So if it is not clear, please let me know. Okay, I hope it is clear then. So once you apply the second clock cycle, what happens again? There will be a shifting like this, because the D flip flop, the next state is the previous input itself. So, and the first, we have to remember that this is tied to 1. So the first state will always be 1. Now the question has asked say to do the same, and it is asking after 3 clock cycles what will be the input. So we have already applied 2, so let's apply the third one and see what is the output. So this will be 1, this will be 1, this 0 will come here, and the first is always tied to 0, right? So after 3 clock cycles, this will be the state for Q3, Q2, Q1, Q0, which is option B. Is the process clear to everyone? Yeah. So yeah, I think this was a simpler question. So if this is clear, we will have some similar type of question in this lecture. So if this is clear, let's try this out. So this is exactly some similar circuit. Okay, I'll explain again. Okay, sure, sure. So this question involved the sequence of some D flip-flops. Now the question said that initially all the D flip-flops are reset to logic 0. That means the initial state of all the flip-flops are 0. The serial input, that is this serial input, it is always 1. The question has stated that, so we cannot change this. And the question asked that what is the output after 3 clock cycles. So as I said that the next state of the D flip-flop is the input itself, that is D. In this case, so Q3 plus will be D3, Q2 will be D2, and Q1 plus will be D1. So basically, whatever the previous state is getting shifted to the right. So this is also called as a right shift register. I forgot to mention this before. So this is, as I said, this is a topic of shift registers. So as the data is getting shifted, now we just need to shift each and at each and every clock cycle, it will be shifted towards the right. So in the first clock cycle, this 3 will be shifted towards the right, and this is tied to 1, as the question suggests that this is 1. Then in the second clock cycle, so these 3 will be shifted here, and it is tied to 1. Similarly, in the next cycle, this is tied to 1, and these 3 will be shifted here. So hence, after 3 clock cycles, this was the output. Is it clear? Whosoever asked? Yeah, sure. So if this is clear, so this is now again a similar question. Again, we have a sequence of D flip-flops, but the only change is there is some combination that has been implemented. So instead of having a direct D naught or a direct shift, there is one shift that is involved, that is involving one XOR operation. So you just need to apply some basic techniques or the XOR implementation. And now the question states that what is if the initial input, so now we have to be very careful that the initial input it's not 0 0 0 0 here, it's 1 0 0 1 here. So this is at initial or the 0th clock cycle, this is the input. So it is asking the same thing after 3 clock cycles. So this is what it is asking. So it is exactly same question, just with some different modifications. So I'd like to give you maybe 2 3 minutes. You can type your answers in the chat box and let me know what are you getting.
0001.
Okay, so there is no option suggest 0001. So kindly recheck your calculations.
Answer C.
Okay, I've got one answer as C. Let's see if other. Sorry. Okay, so I've got one answer as C. So let's see. Let's wait for some more people to answer and then we can proceed. Okay, so I'm not getting another answer. So let me try to solve it by myself. So now as you can clearly see, the Q0 is D0. So I'm just marking. So the Q0 plus will be D only. The Q1 plus will be D1. The Q2 plus will be D2. The Q3 plus will be D3, which is the case. Now, okay, so I've got again C. So let's see if it is correct or not. So the only thing that is changed in this question is the D naught. So D naught, as you can see, is a XOR of Q2 and Q3. Rest the register will work as same. So let's start with the initial content as 1001 and maybe try to make that similar table. So Q3, okay. So the question, yeah. So let's do it like that. So since the right shift is like this, so I will write Q naught first because then the shifting will be in the same line. So Q naught, Q1, Q2, Q3. So the initial content as it says it's 1001. This is the initial clock. So now what is happening is in the first clock cycle, everything is getting towards the right side. So this 1 0, oh sorry, this 1 0 0 will come here, and the D naught, as you can see, that is basically Q naught plus the second cycle. It is nothing but the XOR of Q2 and Q3. So these two. So if I do a XOR of these two, so this will should be the input here. So 0 and 1 XOR is always 1. Then in the second clock cycle, again this 1 1 0 will be here. So 1 1 0. Now the XOR of these two, let me change my pen. So the XOR of these two will come here, which is 0. Change my pen again. So now this again will come like this 0 1 1, and the XOR of these two, maybe green, will come here. So this is 1. So after 3 clock cycles only, the question is asking what is the output. So the output is, so this is Q3, sorry, this is, my bad. This is Q naught, Q1, Q2, Q3. Now the question is asking, I think Q3, Q2, Q1, Q naught. So the final answer would be something like the opposite of this thing, which is 1101. Is there any option like that? Yeah, option D is the correct answer. So I see all of you were saying option B somehow, or option C, sorry. Are you able to understand what was your mistake? Please let me know if it is clear to everyone. Oh, great. I think, yeah, if this is clear, I think we can move to the next problem now. Okay. So now the next problem, it's more of an explanation-based problem. So it is asking about the mod value of the 4-bit twisted ring counter. So do you, any guys have heard about this particular ring counter, twisted ring counter? So mod is nothing but the number of states. Okay. So let me, so this particular twisted ring counter, it is also known as, I don't know if the professor has taught something like this or not till now. It is also called as a Johnson counter. This is a very important topic in terms of counters. So it is nothing, it is again a sequence of D flip-flops. So since this is a 4-bit counter, so there will be 4 flip-flops, and which are again something like this: D3, D2, D1, D0, Q0. So the only difference is, as you are doing the right shift, the only difference in this counter is the Q0 complement is the input of the first. So this is the only not complement, this is the only difference that we have. So what you can do is you can try out. So let's say you can start with the initial state. Maybe I'll do it myself, no problem. So let's say Q2, Q3, Q0. So these are, let's say, 0, 0, 0, 0 initially. So let's say this is initial. So now, as I said, this is again a right shift counter. The only difference is the Q0 bar is the input of the first. So what I can write here is, so this will move here, this will move here, this will move here, and the complement of this will move here. So this will be 1. So I will write here that Q3 plus is nothing but Q0 bar. That is basically D3. Now again at the second clock, what will happen? This will be 1, this will be 0, this will be 0. Now the complement of this, which is this, is 1. Now again it will move 1, 1, 0. Now the complement of this thing, which is this, will be 1. Again this 1, 1, 1 will move here, and again the complement of this thing will be 1. So again what will happen? This 1, 1, 1 will come here. The complement of this thing will be, I'll use, sorry. The complement of this thing will be 0. Again the same thing will happen. So this will be 0, 1, 1. Okay, let me make the arrows so that it is more clear. The complement of this will be 0. Okay, I'm out of inks. Then again, if I write, so this will be 0, 0, 1. The complement of this thing, which is, use this pen, is again 1. Oh, sorry, not 1. The 1 is 0. And at last we have 0, 0, 0. And the complement of 1 is 0. So as you can see, we have reached from the initial state, which was this 0, 0, 0, 0. So this was the initial state, and we have reached back to this state. So these are the total state that this counter will have. So if I do the calculations again, this state will come again, right? So the total number of states now you can even count. So this is, let's say, oh sorry, This is one state, two, three, four, five, six, seven, eight. So it has total 8 states. So this is nothing but a mod 8 counter, which is option B. Or the general formula for the mod value of the let's say a n bit counter, n bit twisted counter is nothing but 2n. So let's say if this would have been a 6 bit, so the answer would have been 12. Is this clear to everyone, the process? So yeah, this is what we call as a twisted ring counter or a Johnson counter. So please keep in mind. So let's move to the next problem now. So it says, what is the output frequency of the following circuit if this clock cycle is there or clock frequency is there when the T is input logic is connected to 1. So we have a T flip flop and we need to find the frequency of the output of this circuit. So you can give it a go and let me know what is your answer. We have got some answers. So we have okay, we have A, C, B. Okay, so we have a lot of difference in the opinion. So let's see. So even if we have difference in the opinion, so let's solve it then. I thought this would have been a direct problem, but yeah, we can solve and clear the logic. So we have a T flip flop as given in the question, which is nothing but a JK connected together. And we have a positive S triggered clock, and we know that this is Q, this is Q bar. So now, as it is positive, so let's take an example maybe. So let's say this is the clock. Yeah, something like this. So since this is positive S triggered, so all the things will happen here. So we know that this is the time period of this clock, which is let's say T clock, something like this. Now the question says, what is the output frequency when the T input is connected to logic 1? So now T, the question says it is always 1, right? So can anyone tell what is Qn plus 1 for a T flip flop? Anyone remember? Okay, it's Qn complement, but when? Okay, so exactly it's Qn XOR T, or if I write in simple terms, Qn plus 1 is Qn when T is 0, and Qn plus 1 is Qn complement when T is 1. Now the question basically has this particular condition because the input or the T is always set to 1. So wherever the positive edge triggering will occur, what will happen? The previous input will toggle, right? So the first positive edge comes here. So let me write the output. Let's say this is output. So what will happen here? So here, since the input is the t is 1, so what will happen? Sorry. So the positive is triggered, the input is 1. Yeah, so it will toggle. So it will, so now the next positive is triggered come here. So now again it is 1. So again the output will toggle. Now again the output will toggle. Are you all able to understand this output? Yeah. So now what you can see is the clock period or the time period of this clock is, let's say, t clock plus t clock, right? It is equivalent to 2 clocks. So basically what I'm trying to say is, let's say the time period of the output is 2 t clock, which makes the frequency of q as frequency of clock by 2, right? So here the question is 10. So the output will be of 5 megahertz, which is option A. Is it clear to everyone? So there would have been some different case if the input is connected to, let's say, logic 0. So if the input would have been 0, then the qn will remain as the previous input, which is the qn, and the output would have been something else, or the answer would have been something else. But since here the t is connected to always 1, so at every positive edge trigger, which is here, here, and here, the output will toggle. So it is toggling, as you can see. Is it clear to everyone? Okay, great. So I think we can move to the next problem now, which is the initial content of the this ABCE is something like 0 1 1 0. So it is asking what are the content of ABC after 2 clock cycles. So I think, I mean, we have done a lot now. I think you will be able to do it. So can anyone tell what is this type of counter? We have just studied, I think. If you are paying enough attention, so you'll be able to know. Yeah, so this is a twisted ring or a Johnson counter. So please let me know the output. So it is asking after 2 clock cycles, considering this is the initial output or the initial input, sorry. So you can take maybe 2 3 minutes again and let me know your answers in the chat box. I want everyone to try and write your answers in the chat box. We have got, I think, matching answers this time. All of you are saying B. So let's see quickly. So it says the initial state of ABCE. So that initial without any clock, it's 1, sorry, not 1, it's 0 1 1 0. So again, it is shifting, and the first will be, this is the first clock cycle. So it will be 0 1 1. And the complement of this, as I said in the previous question, will come here. Now again the second clock, so it will be 1 0 1, and the complement of this thing, which is 1, is 0. Oh, so it is asking after 2 only. Okay, yeah. So this is a very simple question. So after 2 cycles, this is your A B C E. The order of the question is asked of ABC only. So yeah, the correct answer would be, yeah, option B is the correct answer. Okay. So if this is clear, let's move to the next problem. Okay. So it says which of the following statement is true for a given circuit. So this is actually a good question. You can try out the same method that we are applying. You can check for every at every state what is the output that is coming. So each and everything is connected here. So this is kind of a complex circuit, but you will get to see that this is actually a very simple circuit. So you can try out. One thing I need to explain before you can start is, since the options are saying something called as asynchronous and synchronous. So the basic difference between these two words, as the name suggests, synchronous means all the clocks are in sync. That means all flip-flops have a single clock. Asynchronous means different clocks. So as the question as in the question, you can see a single clock is connected to each and every flip-flop, which is these black lines. So this is nothing but a synchronous circuit, right? So you can easily eliminate this option and this option directly. So this is a synchronous circuit. Even the Johnson counter is synchronous as the clock is same, as I have already told. So you can see also here. So this is a Johnson counter. The clocks are connected to all the flip flop, which is same. In asynchronous circuit, there is some relation of the clocks with the previous output or the previous input. So we'll see those questions later. But yeah, this is a synchronous problem. So you can now try out. Maybe you can tell me what are the states that you are getting, and we can deduct some answer from that. So you can take again 2-3 minutes and let me know the answers, and then I'll also try. Okay, first of all, I'd like to know, can anyone tell what are the flip-flops that are here attached? What are the kinds of flip-flop that have been used here? Okay, so try to see it carefully. You can see that J and K are both connected together in all the cases, which is nothing but a T flip-flop. So all of these are T flip-flops. So this is T naught, this is T1, this is T2, this is T3. As we have done the conversion in the previous class for the conversion of flip-flops, when both J and K are connected, it is always a T flip-flop. So let's try out. Maybe I can also do it. So now the question says that T naught is always connected to 1, right? High means 1. So maybe I can write that. So T naught is 1. T1 is Q naught. You can see it. So T1 is Q naught, which is this. Similarly, T2 is Q naught Q1. Am I right? Yeah. T3 is Q naught Q1 Q2. So these are all ended, as you can see. Sorry, not 3, Q2. This thing is clear to everyone, this expressions? Yeah. So let's maybe make a table to explain it. So it says T naught, Q naught, T1, Q1, T2, Q2, T3, Q3. So initially we have a T naught which is 1. So T naught is always 1, as the question says. So we'll do that. Maybe I'll write. So now the Q naught, as you know already, we have just done in the problem. So when t is 1, Qn plus 1 is, anyone quickly? Anyone? Okay, I've got something, I think. No. Yeah. So Qn plus 1 is nothing but Qn complement. So let's say the initial state is 0. Maybe I'll write the initial state 0 for all. So at every clock cycle, what will happen? This will toggle. So this is 0, so this will be 1. Again, it will toggle 0, 1, 0, 1, 0, 1, something like this. Is the queue not clear to everyone? Okay, if it is clear, then we know that T1 is nothing but Q naught. Oh, sorry. Yeah, so T1 is nothing but Q naught. So I'll write this again 0, 1, 0, 1, 0, 0. So now what do we know that based upon the T1, whenever T1 is 1, then the clock or the it will toggle, otherwise it will remain same. So as you can see, it is the case, maybe I'll highlight. So here there is 0 to 1. So here it will toggle, here it will toggle, here it will toggle, here it will toggle, then here it will toggle. Right? So let me try to explain or write the final output for Q2, or sorry, for Q1. So since you can see here is a toggling of 0 to 1. So what will happen? This wait, so Q1 is 0 when T is 1. Okay, let me think out. Mhm. Okay, so the T1 is 1. Oh, okay. So this is the initial clock cycle. We cannot consider this. So let's say we'll start from here. So since this is 0, this will, is this on, what is the output? Okay. So just to be clear, this is actually a negative edge triggered flip flop. I apologize. So you can see it is a negative edge triggered flip flop. So it will only change when there is a transition from 1 to 0, not 0 to 1. So let me do that. I hope you understand what I just said. Is it clear to everyone? The transition will be happening whenever there is a transition from 1 to 0, because it is a negative edge triggered flip flop. Basically what I'm trying to say is this. So if this is the clock, so the negative edge is when it is goes from 1 to 0. So whenever this happens, the T flip flop would work. So let me write the output now. I think it will be more clear now. So 0 to 1 there will be no change, which is 0. Then at every 1 to 0, so there will be a toggle, that means it will be becoming 1. 0 to 1 it will remain same, then 1 to 0 it will again toggle, 0 to 1 it will remain same, then 1 to 0 it will again toggle, 0 to 1 it will remain same, then 1 to 0 it will again toggle, 0 to 1 it will remain same, then 1 to 0 it will again toggle, and yeah, and so on. So 0 to 1 it will remain same, and 1 to 0 it will again toggle. Is the Q1 clear to everyone? Yeah, so now the T2 is the end of Q naught and Q1. So let's do that quickly. So this is 0. Maybe I use blue ink. Yeah, so this is 0. I'm just doing the AND operation. 0, 0, 0, 1, 0, 0, 0, 1. Yeah, so it's just the AND operation of these two, this and this. So now Q2 is again the same thing. So it will toggle when there is only a transition of 1 to 0, which is here, here, and here. So let's write that now. Maybe I can use different pen. So as I said, Q2 will remain same till there is no transition. 0 to 1 same. So 1 to 0 it will toggle. Now it will remain same till here when there is transition. So now again it will become 0. It will not toggle till here, and then it will again become 1. Is Q2 clear to everyone? Okay. Now the T3 is the AND of these three things. So I'm doing the AND
Yes,
operation.
sir, clear.
I'm doing the AND operation now. So this will be 0, 0. Okay, sorry. Yeah. 0, 0, 0. Okay, so it 1, 1, 0. Yeah. This will be 0. Now here 1, 1, 1. Yeah. Sorry, I think. Let me write. Not sure if I got time correctly. Okay, I'll try to make horizontal lines. It is not very clear. Yeah. Now I'll write. So this will be 0, 0, 0, 0, 0, 0, 3, 4, 5, 6, 7, 1. So this is again 0 and so on. Now the Q3 will be only changing when there is this toggling. So there is only one time, and it will, yeah, if we, even if I like make more cycles, let me do that too. Since this is 4 flip-flops, so there will, should be at least 15 states. So 1, 2, 3, 4, 5, 6, 10, 11, 12, 13, 14, 15, 16. Yeah, something like this. So I can easily write now whatever I got, I can, sorry, I can write this as 1, 0, 1, something like this. This is 0, 0, 1, 1. This is, yeah. So now there is this toggling is only happening once. So the Q3 will, yeah, let me write with some different thing. So it will remain the same till the toggling. So here the toggling happens, so it will always remain 1 now till the toggling, and there is no toggling basically. 4, 5, 6, 1, 0. Yeah, something like this. Not sure. So now what do we want is it a up counter or is it a down counter? So let's write only Q3, Q2. Okay, yeah, maybe here. So if I try to write, or if I try to extract Q3, Q1, Q0, Q0 one by one. So as you can see, it will start from here. So it is 0, 0, 0, 0, and it will go till 1, 1, 1, 1. Before it is 0, 1, 0, 1. I'm not sure if I've written this correctly. Yeah, I think there might be some mismatch, but if you see it clearly, so it will be 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0. Okay. Oops, sorry. Yeah, so basically in decimal it is 0, 1, 2, 3, and so on. It will go till 15. So it is counting from 0 to 15. So this is nothing but a up counter. And since this has a same clock, so this is a synchronous up counter and it is 4-bit because it has 4 flip-flops. Is this clear to everyone? The problem and how we have extracted this table. So it is nothing but a 4-bit synchronous sub counter, and those who said Johnson counter, it cannot be a Johnson counter because we just read that in Johnson counter the complement of the final is connected to the input of the first. So hence your answer, I mean, you would have answered it without even trying because we already eliminated option A and D, so the only correct option could have been option B. So I think this is clear to everyone. So let's move ahead. Yeah, so this is again a similar question. It says that which of the following sequence generated by the output. So output we need to find. So what we basically need to find is Q naught. So you'll again make the same table that we made previously. You just need to find what is the sequence that the Q naught is following. Is the question clear? Okay, great. So maybe take 2-3 minutes and then let me know. Okay, so I think I've got few answers. Now I've got D. Okay, so let's try it out. So the only difference was, if you can go back to the previous problem. could have been the same. So I'll do, maybe I'll write it again. So it is Q3, Q2, Q1, Q0. The initial state I think is given as 1001. Okay, 1001. So the only difference is the D3 is the XOR of these two. So XOR of these two will come as a next term. So this will be shifted 1, 0, 0. And the XOR of these two, maybe I'll do some different thing. The XOR of these two will come here. So I'll write it maybe more. Okay, so now this will come here. This will come here. This will come here. The XOR of these two will come here. Yeah. So we write. So again, this will be 0, 1, 1. The XOR of these two will come here. So I'll do it again. So this is 1, 0, 1. The XOR of these two will come here. I don't know if I need further, maybe yeah. So 1, 2, 3, 4, 5, 6. I need at least 6. So yeah, what is the color that is remaining? Yeah, so the XOR of these two will come here, and the same thing 0, 1, 0. So now the question is asked that what is the output? So output is nothing but Q naught. So the cycle of this will be the output. So it is nothing but 1, comma 0, then it's 0, then it's 1, then it's 1, then it's 0. Is there any option like that? So I see someone has said D, someone has said 1, 0, 0, 1, 1, 0. Yeah, it is option A. So yeah, option A is the correct answer. Is it clear to someone has written D? So is it clear? Yeah. Oh, great. So let's move to the next problem then. Okay, so this is again a very good problem. And a similar problem in this, there is three flip-flops. The first and the third are having the XOR connection. So initially we have QA, QB, QC as 1, 1, 1. We need to find the sequence produced by the below circuit. So again, so you need to do the same thing. This is even easier. So let me know quickly what is the answer. Maybe you can take 2-3 minutes and let me know. Okay, so I'm getting mixed answers. So this was a very simple problem. So please try to do it carefully because I'm getting mixed answers. So it's 1, 1, 1. So now the XOR of these two basically will come at the first point. So this one will come here, this one will come here, and XOR of 1 and 1, maybe I'll use different things. So XOR of this and this is 0. Now it's 0, it's 1. XOR of this and this is 1. I'll do it again. So it's 1 here, 0 here. XOR of XOR of 1 and 1 is 0. So basically it started from 1, 1, 1. Then it goes to 0, 1, 1, then 1, 0, 1, then 0, 1, 0. Is there any option like that? I don't see any option like that. Have I done something wrong? Oh, yeah, yeah, yeah. Sorry. So option B is the correct answer. Option B is like that. Is it clear to everyone? Okay, so then let's move ahead. Okay, so again we have what is the output frequency of the logic when the initial clock is 5 megahertz. Assume the initial value of Q logic is 1. Q logic, okay, so initially this is 1, but the connection it's logic 0. So it is asking what is the output frequency of the circuit. So again take maybe 2-3 minutes and let me know your answers in the chat box. I'd like to give you a warning that this circuit is having 0 input. The previous circuit that we did was having logic 1. This is just a hint. So maybe try out and take 2-3 minutes and let me know your answers in the chat box. Okay, so I've got a lot of mixed answers again. Okay, some people are saying A, some people are saying D, some people are saying C. Okay, so I've got A, C, D as the probable answer. So let's see. So it says, okay, let's say we have a clock. Now the circuit is positive edge triggers. For example, this is the clock. Now it says the input or the logic of this circuit is 0. So T is the input, it's always connected to 0. So let me make a straight line. So let's say output is Q, starts from 1 because the question says that is initially it is at 1. So at every positive is triggered. Okay, so again Qn plus 1 will be what when T is 0? It will be Q, sorry, it will be Qn, right? So at this positive is triggered, what will happen? This Q will remain the same, right? It will be Qn only. At this edge, because T is 0, T is always 0, it will remain the same. It will remain the same. Is it, is this make sense to everyone? I mean, this will be a straight line. Is this clear to everyone? Please let me know if this is clear. So what is the answer then? Yeah. So since it is always constant, it is not even moving. So the frequency of this particular thing will be 0. So the correct answer is 0. So all of you have written different answers, but the correct answer was written by no one somehow. I hope it is clear to everyone. So let's move to the next problem now. Yes, is there any doubt? Whosoever raised their hand, is there any doubt?
Yeah.
Nikala.
Qn plus 1 is Qn bar, right? It's T flip flop.
Yeah, so it's Qn when t is 0 and it's Qn bar when t is 1. Question has said that the input is stuck to 0.
No, toggles the input, right?
Yeah, so it toggles only when, so the actual formula as I told, it's Qn XOR t. So it only toggles when the t is 1.
Okay.
Okay, yeah, so let's move to the next problem. Okay, so yeah, this is actually a very good problem. So can anyone tell whether this circuit is a asynchronous or a synchronous circuit? Okay, so those who are saying synchronous, can you tell why? Does this circuit has a single clock which is attached to every flip flop? No. Okay, so there is a confusion. So you see, every clock is dependent upon the previous inputs. It's not the same clock. If it would have been a same clock, it would be something like this, right? So this is a asynchronous circuit because the clock is dependent upon the previous inputs and outputs. Is it clear? So actually, this is a very interesting question. So you need to apply some knowledge. So again, it says identify the output of the following circuits after 6 clock transitions. The initial value of all flip flops are 0. So initially it's 0, 0, 0, 0. So it's a D flip flop. We know that Qn plus 1 is D, or it's Qn only. And if you see in this particular questions, the actual D that is connected, it's connected to Qn bar, right? For all the cases, D is connected to Qn bar. So this is a positive edge triggered flip flop. So let's try it out. I mean, let's make that table again. So since this is a asynchronous one, then we need to write everything. So I'll write Q naught bar, Q1, Q1 bar, Q2, Q2 bar, Q3, Q3 bar. Okay, so this is, let's say, all the initial states are 0. The question says, so maybe the Q naught will be, will be the complement. So this is kind of the initial state. So now you see the only clock that is correct is at the first flip flop, right? So the first, maybe I'll write something like this, then not this. Yeah. So let's say first, second, third, fourth, fifth, sixth. So the question is asking after 6, right? Yeah. Yeah. Now, as I said, the clock is only acting for the first flip flop. So I can easily write that the D flip flop is working, right? So this one will come here, right? Then it will be 0. So this one will come here. Sorry, this 0 will come here. So it will, sorry. Is this clear to everyone? Okay. So now we know that Q naught bar is acting as a clock for this flip flop. So the only time that flip flop will work when there is a 0 to 1 transition, because it is a positive edge triggered flip flop. That means 0 to 1 means his. Uh, is it clear the line that I just said? Okay, great. So what I am trying to say is, if there is no transition, this will remain same. So here is the transition. So what will happen in this transition? This will toggle, or I mean, I'll write 0 1 together because this will remain same. This will come here only when there is this 0 to 1 transition. So this will be what, this will be 0, yeah. So now there is no transition, so this will be, sorry, this will be 1 0. So now there is transition, so this 0 will come here, so this will become 1, again no transition, and again transition, so this one will come here. Is the q1 clear? Okay, great. Now what we'll do is we'll do the q2. Now you see that the q1, okay, so yeah, I mean, I hope you all know. So this is q0, this is q1, this is q2, this is q3. So now the q, okay, the q, what is this thing? 1. So q1 is acting as a clock to q2. So this is the clock, and the only 0 to 1 transition that is happening is here. Rest it will remain same, right? So this will be 0 1, this will be 0 1, this will be 0 1. Here the transition happens, so this 1 will come here, this becomes 0 1 0, and this is also 1 0. Is this step clear? Okay, so now the last steps comes, which is, so you see there is no 0 to 1 transition here. So since the q2 bar is now acting as a clock to this particular flip flop, so there is no 0 to 1 transition happening here. So it will always remain 0 1. Please explain again. Okay, so what part did you not understand? Can you please let me know? Hello?
Can you explain the Q bar connected to the other flip flop? It's not clear. I can't see the question.
Okay, okay. So what I'm saying is, let me. So what I'm saying is every flip flop clock, which is this clock, is connected with Q naught. That means it is a positive edge triggered clock, and it will only work when there is a transition of 0 to 1. Right? So what I was trying to say, whenever there is a 0 to 1 transition in Q naught, there will be a transition in the next state. For example, here also, whenever there is a 0 to 1 transition, there will be a transition in the next state. And if there is not that case, then this will remain same always.
There will be a effect of D flip flop also,
Yeah,
right?
yeah, yeah.
D is the input, right?
Yeah, yeah. So D is the
So
input, that is true, but the D is actually connected to Q bar. So yeah, you are right. So Qn plus 1 will be D, which is actually connected to Qn bar. You see? I mean, for all the flip flops, the D is connected to the complement. So hence I am doing the complement.
no, it's not clear. See, D and Q bar are connected. That is fine.
Yeah.
In the first state would be zero. Okay, okay. The next state will be one for it, right?
Uh,
Q, Q naught will be one.
Next Q naught, that is this, right? This will be one. I mean, yeah, this will be complement, right? Are you referring to this?
No, saying the second state. Second state Q naught one is uh,
Second state
one.
means this row.
Yeah,
Okay, yeah. So, okay.
but if I traverse through this, no, the clock will be one at which situation? It is not clear.
So the first clock is always there. So at the first clock, at every clock, this particular flip flop will work. So whenever first means whenever there is first positive edge triggering, what is happening? This is actually working. I mean, this will always toggle, right? Because D is Q and bar. I mean, this line will always be 0 1 0 1 0 1 0 1.
Is there any expression that you could give for clock? Like we gave for J flip flop and Qn plus 1 is equal to some D. For D, it is D, right?
Yeah.
Can we derive some expression like that for this also?
No, no. So it is actually this only. There is nothing different. What I'm trying to say is, okay, so let's forget about that this circuit exists. Let's see only this. If you see
Okay.
the left hand side, so this is the clock. The Qn plus 1 for this flip flop is actually D that you know, and it is connected to Qn complement, right? So let's say if you have given it 0, let's say for example initially, so the next state you know it will be Qn complement, right? So it will be 1, right? At the clock edge. Are you able to understand this?
Yes.
Yeah, and then it will go on. So it will act like a toggling circuit. So it is actually a T flip flop because it is connected like that. Is it clear now?
Okay. Okay.
Yeah. So yeah, so question was asking what the initial values are all this. Identify the output after 6 clock transitions. Okay. So the output is Q naught, Q1, Q2, Q3 at 6 is so this. So it's actually 0, 1, 1, 0. Q naught, Q1, Q2, Q3. Okay, so question is asking the opposite. Let me write. Oh, so it will remain same. It was like the palindrome only. So the correct answer would be option D. Uh, I hope it is clear. Is it clear to everyone? Okay, so let's move ahead. It says consider the Johnson counter and the clock timing as shown is a figure below. Let the initial state be this. Consider the delay of input and output is 1 millisecond. After how much time the output will become 0? Okay, so this is a very easy question if you think conceptually. But even if you want to solve, you can do it and let me know the answers in the chat box. Yes, is there any doubt?
Yes, sir. Please, can you explain the last one?
Which one?
Yes, last one, sir.
The previous question?
Yes, sir.
Which part?
Sir, sixth one.
Sixth one means this last row.
Yes, sir. Last two.
No, no. So I have done it like this. So I've solved this first, then this, then this. So as I said that this Q naught will transition every time. So the Q naught bar I have written like the opposite of this. So once we have this, the only key takeaway of this question is the clock is actually this. So for the next flip flop, which is let's say this D1, the clock of the circuit is Q naught complement. So it will only happen when there is a 0 to 1 transition, or it will only work or it will only process when there is a 0 to 1 transition. So this 0 1 will remain 0 1 till there is this transition. Once this transition happens, there will be this one which has come here, or it has become the opposite of that because the D bar is connected to sorry, the Q bar is connected to D. And yeah, the same thing goes for each and everything. So whenever there is a 0 to 1 transition, as you can see in this, so there is a transition here. Similarly, there is no 0 to 1 transition here, hence there is no transition in the last cycle. Does it make sense?
Yes, sir. Clear.
Okay. So yeah, so this is again okay. It is already written that this is a Johnson counter, so it is a mod. Since this is we have 4 flip flops, this is 8 states, right? So basically 0 0 0 0 will be the first state. The next state will come after 1 millisecond, as the question said. So which is nothing but we have just done that. So it's 0 0 0, and this will be 1, which is the complement of this. Then 1 1 0 0, so on, and it will go to 0 0 0 0 at the 8th state. So 1 milliseconds times 8 is the answer, which is very basic. So 8 millisecond is the actual answer. This was an easy question. Shall I move ahead? Okay, yeah. So this is again a good question. So it says suppose a 4-bit Johnson counter, again, which is the problem previously, is initialized with the sequence 1111, which of the following value converted to decimal will not occur? So as you see that 4-bit means it can have a total of 16 states, right? 1111, I mean, yeah, total 16 states, but the actual state is the mod of that counter is 8. So there are 8 states which do not occur in the Johnson counter. So you need to find which of these states are not occurring in the decimal value. So let me know your answers in the chat box. Maybe you can take 2-3 minutes and let me know. Okay, so I've got one answer. Let's see. It's 1111 as an initial state, which is, let's say, Q3, Q2, Q1, Q0. So this will be 1110. This will be 0110. Will be 0010. This will be 0000. This 0001. 100111110, then 1111. So if I convert it to the decimal value, this is 15, this is 7, this is 3, this is 1, this is 0, this is 8, this is 12, this is 14, and this is 15. Again, yeah. I hope I've written it correctly. Yeah. So you see the only states that are possible are 0, then 1, then 3, then 7, then I don't know, 8, then 12, 14, 15. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. So as you can see in the question, so 7 is there, 3 is there. Is there any 5? Yeah. So 5 is not there. The correct answer is option B. Is this clear to everyone? Okay. So let's move to the next problem. This is a good problem again. So it says in the following diagram, register A and B were loaded with these values. Okay. So register A is this, B is this. So let me write. These are loaded with these values, something, something. This is 10010001. Yeah. The flip flop was initially reset. So the flip flop means this is the flip flop, which is the T flip flop, it is saying. Okay, so let me maybe make it clear. So this is CI minus 1, this is CI, this is BI, this is AI, this is SI. So this is a full adder. And the question is saying after the 8th clock pulse, what will be the loaded sequence in register A? Okay, so this is actually a very good question. So what is basically happening is these two inputs are getting one by one serial out and getting input. So maybe, yeah, I'll just write. So I'll make a clock, maybe first clock, sorry. Yeah. So as the resistance, this is AI, BI. So there could be a CI minus 1, which is the third input, then the sum and carry. Yeah. So let's do after 8 clock pulse, it is saying 5, 6, 7, 8. So AI is, so this is getting in first. So 1 1 is getting first, then 0 0, then 0 0, then 1 0, then this is 0 1, 0 0, 0 0, and last is 0 1. So this is the question, and it is asking what is the output, or what is after 8 clock pulse, what will be the loaded sequence in register A. Is the question clear to everyone? Now it says clearly the flip-flop is initially reset. That is means this Q or Ci minus 1 is 0 initially. Right? So what will be the sum and carry of the first one? Can anyone tell? Anyone? You don't know what is the sum and carry of a full adder? Yeah. So sum will be 0, carry will be 1. So 1 plus 1 plus 0 is basically 1 0. So that is correct. So now what we need to do is this Ci is actually getting here. You see this Ci is connected to T. So when this is T, there will be a toggling and this Q will become Q bar, right? So this will be 1, no? Is this clear to everyone how I've written this one? Please let me know quickly if it is clear. Okay, great. So now what is the sum and carry? Sum will be 1, carry will be 0. So now since the carry is 0, this will remain the same. Now again the sum will be 1, carry will be 0. Again since this is 0, it will remain the same. Now the sum is 0, the carry is 1. Now since this is 1, so there is one transition is here, one transition is here now. Because Ci is 1, so that it will toggle. Now the sum will be 1, carry will be 0, it will remain the same. Sum will be 0, carry will be 0, it will remain the same. Sum will be 0, carry will be 0, it will remain the same. Sum will be 1, carry will be 0. Is this clear to everyone? Please let me know if this table is clear, then you have the answer. So basically what is happening, this Si is getting fetched to this register A, right? This Si, if you see, it is connected to the serial input. So basically this is the input after 8 clock cycles. I mean, so this will be the most significant bit. Sorry. Yeah, so this will be the most significant bit and this will be the LSB. So after 8 clock cycles, the sequence that will be there is 1 0 0 1 0 1 1 0. So this will be there like this in the register A. Which is option? Is there any option like that? 1 0 0 1 0 1. Yeah, option B is the correct answer. I hope it is clear. Please let me know if it is clear. Okay, great. So let's move ahead. So it says what is the output after 2 clock pulses for a bit sequence 1101 sequentially entered in a 4-bit parallel out shift register. Okay, and it is initially clear. So you see, we have 4-bit register, shift register. So basically every box is a like a flip-flop, as we have already made those circuits. I'm not making it. I hope it is like quite well understood now. So it says we are sequentially feeding this 1101, right? So this shift register, it will at the first clock it will be 0 0, and then this one will be fetched here. The next input will be 1 0 0. Then this 0 will be fetched here. Sorry. Then this will be 0 1 0. Then this 1 will come here. Then it will be 1 0 1. Then this one will come here. So this will be basically, oh sorry, the question said what? After two clock pulses, sorry. So this is the first, this is the second, third, fourth. So after two clock pulses, this will be the actual input, which is option, is there any option? Yeah, option 4. Is this clear to everyone? Okay, great. Let's move ahead then. Again, we have a similar question. And again, we have the same 4-bit serial in parallel out. Initially, it's 1111. The data to be applied is this. After 3 clock cycles, what will be the output? So do it, take 2 minutes and let me know the answers in the chat box. Okay, so I've got some answers. So let's see. Initially, it is set as 1 1 1 1. We need to feed 1 0 1 0. So again, the same thing will happen. Will be 1 1 1. This 0 will come here. It will be 0 1 1. This 1 will come here. It will be 1 0 1. This 0 will come here. It will be 0 1 0. This one will come here. So it says after, so this is first, second, third, fourth. It says after 3. So after 3 means this, which is option, what is this option? Oh, option 2. Yeah. Okay. Is this clear to everyone? Okay, so let's move ahead. Again, we have a serial in parallel out 4-bit register. The initial contents are given, but there is some XNOR relation. So this is a XNOR gate. It says that the register has this after 4 clock pulses. What are the content? So this is again a same question. Please let me know the answers in your chat box. Maybe take 2 minutes and let me know the answers. Okay, so is there any answer, anyone? But this was a simple question. Is there any problem in solving this?
Sir, can I leave the meeting?
Sorry?
Sorry, sir, I don't know what that answer.
Fine, so let's try to do it. So the initial content again it's 1100. So there will be a right shift of 110, and then the first input will be the XNOR of these two, right? These two. So every time there will be a XNOR of these two. So 00 means 1. This is 111. XNOR of these two will be 0. So it says after 4 clock pulses. Okay, so this is first, second, third, fourth. So this will be 0, 1, 1. The XNOR of these two will be 1. So this is 1, 0, 1. The XNOR of these two will be 1. So after 4th clock, it will be 1101, which is option 2. Is this clear to everyone? Okay, yeah, great. So I think I have covered almost all the problems that I have for this circuit. So again, I'd say that these two or these things that I have marked are the most important topics for this particular course. So please do watch previous week's lecture also, because in that I covered the sequential circuits more, or to say more detailed, more in a detailed manner. And in this in this week we have already covered counters and shift registers. So the only topic that is, I think, the most important topic is the finite state machines that we'll be doing in the next lecture. So again, as I said, the main content of this course started from this only, which we covered, or we started from doing week 6. So again, I would say that if you have not attended the lecture, please do watch the week 6 onwards videos again, because those are the most important parts of this particular lecture. And maybe if there is no doubts, then we can wrap up the session for today. Is there any doubt, please, anyone?
No, sir.
Okay, great. So I think we can wrap up the session for today. We'll meet again same time next week. Uh, so yeah, let's see you then. Thank you everyone for joining.
Bye, sir.